TechDaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com. Data, it's just exploding around us, isn't it? I mean, generated by everything from our phones, smart devices, these huge corporate systems, and the relentless rise of AI. But the big question isn't just how much data there is. It's more like where and how do we actually keep it all, keep it safe, accessible when we need it, and manage all of that without breaking the bank. That's the real challenge.
Welcome to the Deep Dive. Today we're going to jump into a stack of recent reports, articles, online discussions, stuff that paints a really compelling picture of the future of data storage and management, looking ahead to 2025 and well beyond.
Yeah, and our mission here really is to cut through the noise. We want to pull out the most important insights, those key nuggets of knowledge from all this material. The goal is to help you understand the key trends, the technologies coming up, and also the big challenges that are fundamentally reshaping how we store and manage data, whether you're dealing with, massive enterprise systems or even just your own personal files.
So get ready. We're going to explore, pretty much everything. From data centers getting smarter with AI, the push towards the edge, and even the perhaps surprising idea that local storage might actually be making a comeback. It's a complex picture, definitely evolving fast.
Right. Let's maybe start by setting the stage, just looking at the sheer scale of this market. The reports we looked at show that the next-gen data storage market, it's not just growing modestly, it's projected to jump pretty significantly. We're talking about going from around $65.1 billion this year, 2024, all the way up to $90 billion by 2029. That kind of growth, it's not just a number, right? It really underlines how vital, how strategic this whole area is becoming for, pretty much everyone, businesses and individuals.
90 billion. That's a huge leap in just 5 years.
Yeah.
Okay, let's unpack that. What's actually driving that growth? What are the fundamental shifts happening right now in how we even think about storing data?
Well, one absolutely huge shift is right down at the hardware level. We're actually at kind of a watershed moment. For the very first time, SSD and flash storage capacity deployments. They're projected to actually outpace traditional hard disk drives, HDD.
Really, outpace them.
Yeah. Think about that. The faster, the more durable, the more energy efficient tech is set to become the dominant force for new capacity being rolled out.
So solid-state drives, SSDs, finally overtaking the spinning disks we've relied on for decades.
Yeah.
What is it about SSDs that makes them such a game changer here?
Well, beyond just the obvious speed and durability, it's the advancements within the tech itself. Things like 3D NAND technology. That's pushing the limits for density and performance.
3D NAND.
Yep.
That's stacking the memory cells, right?
Exactly. Stacking them vertically so you can pack way more data into smaller physical spaces. And we're seeing enterprise-grade SSDs becoming like the default choice now for applications that need really high performance and reliability. It's moving way beyond just consumer laptops.
Okay, so faster, denser, more efficient drives are becoming the standard. Got it. What about outside the hardware itself? Where is all this data actually, living? It still feels like the big conversation is always the cloud.
Oh, absolutely. Cloud storage is definitely continuing its massive expansion. It offers that, almost limitless scalability and flexibility when you need it. But the really big trend the material highlights isn't just like everyone moving to the cloud. It's the widespread and very deliberate adoption of multi-cloud and hybrid cloud strategies.
Multi-cloud and hybrid.
Yeah, businesses aren't just picking one cloud provider anymore. They are intentionally using multiple cloud platforms right alongside their own existing on-premises systems.
Why do that? Why deliberately manage storage across multiple clouds in your own data centers? That sounds incredibly complex to manage.
It definitely adds complexity, no doubt.
Yeah.
But the strategic reasons are compelling enough that businesses are doing it. Key drivers are things like avoiding vendor lock-in, not being tied to just one provider. Enhancing disaster recovery is another big one, having data spread out geographically across different platforms, and also meeting those really strict data sovereignty requirements.
Right. Making sure data stays within certain borders.
Exactly. Ensuring data is stored and processed within specific legal jurisdictions. It's fundamentally about building resilience and maintaining options, flexibility.
So it's a conscious choice not to put all your digital eggs in that one cloud basket. That makes a lot of sense strategically, especially with how fast things change. Okay, and underpinning all this, especially for the the new applications being built right now, the ones designed to be super agile and scalable?
Right. The foundation there is increasingly cloud-native architecture. The material we looked at predicts that by 2025, approaches using things like microservices, containers, and Kubernetes. They're becoming the absolute standard for modern app development.
Microservices, containers, Kubernetes.
Yeah.
Not just buzzwords then.
Definitely not just buzzwords. Microservices, they break apps into smaller, manageable chunks. Containers package up the application and everything it needs to run consistently anywhere. And Kubernetes is like the conductor, the orchestration system that automates deploying and managing all those containers at scale.
Oh, okay. So it's a whole different way of building software, specifically for this distributed cloud-first world.
Precisely. And this whole shift, it's completely driven by the demand for applications to be agile, to scale up or down really quickly for unpredictable workloads, and to be resilient if something fails. The sources are projecting, get this, over 95% of all new digital workloads will be deployed on these cloud-native platforms.
95%?
Yeah. That's a fundamental reshaping of the application landscape. And of course, all these new applications need dynamic, flexible storage sitting underneath them.
Okay, now here's where it gets really interesting, I think. Connecting storage to maybe the biggest tech trend right now, AI. How is artificial intelligence playing into this whole evolving storage picture? It feels like AI touches everything, and storage must be absolutely central to what AI needs.
It really is. AI is integral in a couple of key ways. First, AI is being used for managing storage itself.
Managing the storage.
Yeah. Well, think about AI algorithms analyzing how users access data. Based on that, it can automatically move data to the most cost-effective storage tier, or the fastest one if needed. That's called data tiering. AI is also being used for optimizing resource allocation within the storage systems, predicting and preventing performance issues, maybe reducing costs. It can help with provisioning storage capacity and even enhance data protection. Things like predicting potential drive failures before they happen or helping automate backup checks.
So AI is basically making the storage infrastructure itself smarter, more self-managing.
Kind of, yeah. But then there's the other side, using storage for AI applications, especially the ones that need absolutely massive data sets for training models and running inference.
Right, the data for AI.
Exactly. AI and machine learning capabilities are increasingly being embedded directly into cloud storage services and platforms. This allows for automating operations and enhancing decision-making about the data, using the data itself. Some reports suggest that enterprises using these AI-enabled cloud services could see pretty significant boosts, maybe up to a 30% increase in operational efficiency by 2025.
30% is huge.
It is. You'll see more AI tools available right within these platforms for things like predictive analytics, automated workflows, and all of that relies on having these vast, well-managed, accessible data sets.
And this whole conversation about processing data, AI, it leads us straight to the rise of edge computing, doesn't it?
Yeah.
This idea of getting compute power and storage much, much closer to where the data is actually created or used.
Precisely. Edge computing is gaining enormous traction. It's really propelled by the sheer number of IoT devices out there, sensors, cameras, factory robots, everything, and also the rollout of faster 5G networks that can connect them reliably. The core idea is simple but really powerful. Process data close to the source. Why? To drastically cut down latency, that delay in communication, which is absolutely critical for any kind of real-time application.
Can you give us some solid examples? Where is edge computing, not just theory, but actually powering these real-time needs today or very soon?
Sure. The reports point to several compelling areas. AI-powered gaming is one. Running AI models locally or on a nearby edge server gives a much smoother, more responsive gaming experience compared to sending data way off to a distant cloud.
Okay, gaming makes sense.
High-frequency financial trading is another classic example. You need servers physically placed as close as possible to the stock exchanges to shave off microseconds. And immersive XR applications, extended reality, AR, VR.
Right, virtual reality, augmented reality.
Yeah, those demand extremely low latency for a believable interactive experience. Edge computing is pretty much essential for delivering those super fast responses needed for AI inference in all these scenarios.
So edge isn't just for these highly specialized sort of niche applications anymore. It's becoming a more standard part of the overall infrastructure picture.
Absolutely. It's rapidly moving from being a specialized thing to being an integral component of modern IT infrastructure. It's really seen as the next logical step for handling big data workloads more efficiently. Think about it. Instead of constantly sending massive amounts of data back from IoT devices or financial markets, or even the data generated by Gen AI models, the edge lets you do that initial processing, filtering, analysis closer to where it starts. That speeds up insights, speeds up actions, and can actually reduce the load on your network.
Okay, that makes sense. Shifting gears slightly.
Yeah, moving on. Another really fascinating trend that came up in the material is this increasing convergence of file and object storage. Now, traditionally, these have been pretty separate worlds in storage.
All right, file storage is, well, it's what most of us know, isn't it? Folders, subfolders, that whole hierarchy on your computer or network drive. Object storage is different, though, right? It's less structured, more like big buckets.
That's a decent way to think about it. Object storage uses a flat architecture. No nested folders in the same way. Each piece of data, they call it an object, is stored with a unique ID and usually rich metadata describing it. It was really popularized by cloud providers, like Amazon S3 is a famous example. And object storage is inherently really well suited for handling absolutely massive, often unstructured data sets.
Like what kind of data?
Think scientific research data, huge libraries of images or videos, the data lakes used for big data analytics, large-scale AI applications, also for compliance data retention, where you might need to keep petabytes of data stored away for years.
And this convergence trend means you can now access both file and object data from the same system.
Exactly. Vendors are now offering NAS appliances network-attached storage that support both file protocols and object protocols simultaneously. This gives organizations tremendous flexibility. They can use traditional file shares for user data for applications that need that structure, but they can also leverage the scalability and often lower cost of object storage for those huge archives or data lakes, maybe even automatically moving data between the two based on policies, like how often it's accessed or how old it is.
Combining that traditional file access with the massive scale of object storage. Yeah, that sounds really powerful for managing different kinds of data more efficiently.
Right.
You also mentioned composable storage. That's a term I'm hearing more. What exactly is that, and why is it becoming important now?
Right, composable storage. It's really a direct response to the increasing variety of storage types we're seeing in data centers, like the huge growth in SSDs we talked about, and the constant need to integrate and manage all these different types efficiently. It's built on the bigger idea of composable infrastructure, which basically allows organizations to dynamically pool and reconfigure the fundamental building blocks of the data center compute, storage, and network using software, using APIs.
So you're not stuck with fixed hardware configurations. You can kind of rearrange things on the fly using software.
Precisely. For storage, it means you can react dynamically to changing application demands. You can reconfigure storage resources, maybe assign a big chunk of fast SSDs to a high-performance database, and then later reallocate those same SSDs to something else, all while things are running, without physically moving cables or drives. This helps tackle those old problems, like resource silos, where storage gets dedicated to one app and then sits idle much of the time, or just general underutilization. It offers really crucial flexibility, and it also helps with sustainability, using the resources you have more efficiently, especially when technology is changing so fast.
Making the underlying storage infrastructure much more flexible, more adaptable.
Okay.
And is this also tying into tighter integrations with virtualization platforms? Things like VMware, Hyper-V, Proxmox.
Yeah, definitely. It's going beyond just, certifying that storage works with virtualization. Some storage vendors are now actually allowing users to run virtual machines directly on the storage appliance itself, kind of blurring the lines between storage and compute.
Running VMs on the storage box. Interesting.
Yeah. And others are offering software-only storage solutions. These are designed specifically to run on standard virtualization hosts. So organizations can build highly available storage clusters natively right on top of the virtual hardware they already have. It simplifies management, especially for heavily virtualized environments.
Okay, now while we're diving deep into all this cutting-edge stuff, cloud, AI, edge, composable infrastructure, one perspective that popped up in the materials, particularly from online forums and discussions, suggests that good old local storage might actually be making, well, a bit of a comeback. At least for individuals and maybe smaller setups.
Yeah, that discussion point, you definitely see it in consumer tech, forums, blogs. It's genuinely interesting because it reflects a totally different set of priorities, right? It really captures user frustrations with certain aspects of cloud services. Things like those lingering privacy concerns. Where exactly is my personal data? Who has access? There's also a feeling of subscription fatigue.
Oh yeah, paying monthly fees for everything.
Exactly. Paying recurring fees for services that maybe used to be a one-time purchase. And then there's the very practical bottleneck of internet speed, especially upload speeds. That can really impact how well cloud storage works for large files like video projects or photo libraries.
So the idea is that something like a NASBox network attached storage sitting physically in your home or small office, people are looking at that again as a solid, reliable, maybe more empowering alternative than just relying purely on cloud providers.
Exactly right. The arguments you hear supporting local storage often include that strong feeling that it's just inherently safer. That phrase, not your hard drive, not your data, it really resonates with some people. And, people have bad experiences. Cloud services changing their terms suddenly, imposing new storage limits, or, worst case, even going out of business, leaving users scrambling to get their data back. Keeping data local avoids dealing with those kinds of other people's business unknowns, as someone put it.
It also touches on that idea that tech trends aren't always just a straight line forward. Things can be cyclical, can't they? Like, we went from centralized mainframes to distributed PCs, then back to the seemingly centralized cloud. And maybe now we're finding a new balance where local options have renewed appeal.
That perspective definitely comes through in some of those discussions. And there's an argument that cost savings can drive these cycles too. While cloud storage was initially often marketed as super cheap, prices have evolved, especially if you need large amounts of storage or access it frequently. So some users are reevaluating the long-term cost of owning their hardware outright, even when you factor in the initial purchase price and, the effort to set it up and maintain it.
And accessibility is a huge factor now, too, with local storage, isn't it? I mean, large capacity hard drives, even big SSDs, they become incredibly cheap per terabyte. It makes it easy and pretty affordable for individuals to just hoard terabytes and terabytes of data right there in their own home or office.
Absolutely. The cost per gigabyte for local drives is often much lower than many cloud tiers, and while local storage offers that immediate control, that perceived safety, often faster access, especially for uploads. The discussions also point out that for many people, the most appealing solution isn't purely local or purely cloud, it's actually a hybrid approach.
Combining the two?
Yeah, combining the benefits of local control, speed, maybe lower long-term cost, with the flexibility and the crucial offset protection of cloud storage for backups or for remote access when needed. Perhaps using the cloud strategically for specific things without feeling locked into a recurring subscription for their entire digital life archive. Okay, now shifting focus a bit. As data centers and these distributed storage systems become even more central to, everything in the global digital economy, holding all this critical data for AI, cloud, IoT, the security threats they face are becoming incredibly complex and pretty sophisticated.
Security is always a huge topic, but what are the top security challenges that data centers and modern storage setups are specifically dealing with as we look towards 2025 and beyond? What did the reports say?
The sources consistently point to several key areas. First, just the sheer evolution of cyber threats themselves, including things like advanced persistent threats, APTs.
APTs. Those aren't your average hackers, right?
No, these are typically highly organized, often state-sponsored groups. They're designed to infiltrate systems quietly, stay hidden for a long time, and then steal data or cause disruption by exploiting subtle vulnerabilities. It's not smash and grab, it's long-term espionage or sabotage.
Okay, so stealthy, long-term attacks. What else?
Then there's the added complexity that comes from using hybrid and multi-cloud environments. Trying to manage consistent security policies, identity controls, monitoring across all these different platforms from different vendors, it's a huge challenge. It creates more potential weak spots and makes it much harder to prove compliance across everything. Supply chain vulnerabilities are another massive concern.
Like the SolarWinds attack.
Exactly like SolarWinds. Attackers compromising hardware or software components before they even get installed in the data center. That can be devastating.
So attacks are getting smarter. The places to attack are spreading out.
Yeah.
What else is high on the worry list for data management security?
Insider threats. They remain a persistent and difficult risk. This could be a malicious employee or contractor or just someone making a careless mistake. But because they have legitimate access, it's really hard to detect. And ransomware. Ransomware and data extortion are just escalating like crazy. They've moved beyond just encrypting your data. Now it's often double extortion.
Extortion.
Yeah, they steal a copy of your sensitive data first, then they encrypt your systems, and then they threaten to leak the stolen data publicly if you don't pay the ransom. It directly targets the huge value of the data stored in these centers.
And thinking back to edge computing and all those IoT devices, that just blows the network perimeter wide open, doesn't it?
Yeah.
Pushing potential weak points way outside the traditional data center walls.
Absolutely. Security can't just stop at the data center door anymore. It has to extend right out to those distributed edge devices and the networks connecting them. Implementing really robust security measures across this whole distributed landscape is just, well, it's non-negotiable. This means adopting principles like zero trust architecture.
Zero trust.
Yeah.
Basically, trust nothing, verify everything.
Pretty much. Verify everything trying to connect or access resources no matter where it's coming from. It also requires advanced encryption for data, both when it's stored at rest and when it's moving in transit. Strict granular access controls who gets to see what, continuous monitoring for any suspicious activity, and just diligent, regular patching of vulnerabilities across every single system. It's a lot.
And compliance must be a massive headache on top of all that, especially with global privacy rules like GDPR in Europe, CCPA in California. They're always being updated, always enforced.
It's a monumental challenge, honestly. Data centers, anyone managing significant amounts of data, they're under intense pressure to ensure data privacy and comply with this really complex web of regulations. Often stringent, sometimes conflicting rules across different countries and states. Failure to comply, that can mean crippling fines, massive reputational damage. Managing that level of complexity across distributed, hybrid, and multi-cloud environments, it's an ongoing operational and technical battle that needs dedicated teams and expertise.
Okay, so beyond the crucial security and compliance pieces, there's another big focus growing rapidly. The environmental impact. All this digital infrastructure.
Yeah.
It uses a ton of power, right?
Yeah, sustainability is definitely moving center stage in the data storage world. Traditional data centers are huge energy consumers, no question, especially for the compute power and, critically, the cooling needed to keep everything from overheating. So the strong trend now is towards green data centers, facilities explicitly designed to minimize their environmental footprint.
How do they do that?
Several ways. Powering them with renewable energy sources, solar, wind, investing heavily in energy-efficient cooling innovations. That can range from optimizing airflow management to much more advanced liquid cooling techniques, where servers are directly cooled by liquids instead of just air. And even using AI itself to optimize energy management within the data center in real time.
And using the cloud itself, can that play a role in sustainability efforts too?
Yes, potentially. Cloud storage can help by reducing the need for every single organization to build, power, and cool their own large physical data center on their premises. The major cloud providers, they're investing enormous amounts in sustainability initiatives, setting really ambitious goals like achieving carbon neutrality or running entirely on carbon-free energy. While using the cloud still consumes energy, of course, these large providers can often achieve greater efficiency and use more renewables at scale than individual companies might be able to. And using those hybrid and multi-cloud strategies we talked about, that can also enhance overall sustainability, potentially, by enabling more efficient resource allocation across platforms and maybe reducing the need for redundant physical storage in multiple places.
And just managing the data itself more intelligently.
Yeah.
That can also help make things more sustainable, right? Like archiving data you don't need all the time.
Absolutely. Intelligent data management practices are really crucial for sustainability. Moving data that's not accessed frequently off those expensive, high-performance, energy-hungry storage systems, moving it to lower-power, long-term storage tiers, sometimes called cold storage, using things like high-density hard drives or even modern tape libraries. Doing that significantly lowers the overall energy consumption and the operational costs. Plus, techniques like data deduplication, which cleverly eliminates redundant copies of the same data and compression. They help reduce the total amount of storage space needed. That improves overall efficiency, which directly helps sustainability by needing less physical hardware and consuming less energy to store the same amount of useful information.
Okay, so we've covered a huge amount of ground here. The data explosion, faster drives taking over, the shift to multi-cloud and the edge, making infrastructure more flexible and composable, even this potential resurgence of local storage. All happening while facing these massive security threats and growing sustainability pressures. What does all this complexity actually mean for, individuals and especially businesses trying to navigate this future?
Well, for businesses, just managing the inherent complexity of these distributed hybrid and multi-cloud setups, implementing robust security across that much wider attack surface, staying compliant with all those constantly changing global regulations, It requires a really significant depth of specialized expertise. And this is where things like cloud managed services are becoming incredibly critical. They allow organizations to essentially offload the heavy lifting, the burden of managing this complex, dynamic, risky infrastructure and security landscape onto specialized experts. That frees up their internal IT teams to focus more on strategic projects, on their core business goals.
It really sounds like just finding and keeping people with that specialized knowledge is
Yeah.
a major challenge in itself.
It absolutely is. And that leads directly to another key prediction that came up again and again in the material. The cloud skills gap persists. In fact, it might even be widening. The demand for skilled professionals in these critical areas, cloud architecture, DevOps practices that bridge development and operations, and especially cybersecurity, it continues to significantly outpace the available supply of people with those skills. So addressing this through robust internal training programs, upskilling existing staff, investing in education partnerships, it's crucial for organizations if they want to effectively build, secure, and manage their data infrastructure going forward.
So if we try to pull it all together, we're seeing data just absolutely everywhere, aren't we? At the core network, pushed right out to the edge, living across multiple clouds at the same time. We need incredibly flexible, highly secure, and increasingly sustainable ways to store it, manage it, process it. We're using powerful tools like AI to help manage the complexity, but that in turn brings its own set of security questions, ethical considerations we touched on. And even with this undeniable push towards cloud and edge, the idea of keeping some data local, maybe under your direct control, that's not disappearing, especially for individuals or smaller outfits worried about privacy, control, predictable costs. It really feels like the future of data storage isn't about finding one perfect location or one perfect technology that wins out. It's much more about finding the right intricate balance and combination of all these different approaches: core, cloud, edge, local, tailored for different needs, different types of data, and different priorities.
Yeah, and this whole complex landscape, it raises a really important question. Something maybe to leave you, the listener, to ponder. In a world where data is constantly being created, constantly moving, being processed maybe closer to where it starts or across all these distributed clouds, how does your current strategy for managing your data need to evolve to keep pace? Are you primarily prioritizing control or cost, accessibility,
Okay.
performance, sustainability? And maybe the toughest part is, how do you find the right, perhaps sometimes uncomfortable, balance among all of those competing demands for your specific situation and your future needs?
TechDaily.ai, your source for technical information. This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconvergent VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.